In this video, I am going to do two problems on assignment problem of module 2. And as you know, what is assignment? Assignment means you are going to assign some jobs to some facility, some facility to some jobs, or some jobs to some facility. So and also you know that the number of the assignment matrix will have number of rows and number of columns same, that is a square matrix. And for this example, I am going to give you this example. Suppose there are 4 machines are there, A, B, C, D, and these machines are operated by 4 operators. Okay, 1, 2, 3, 4. And according to their operators' experience and everything, the effectiveness matrix is given by this one. Suppose if I assign machine A to the operator 1, the cost of assignment is 10. Similarly, cost of assignment means this is either in the rupees, or it can be taken as manpower, it can be taken as hour of operation and all those things. Okay, so A will be assigned to one first operator, it will cost 10. Suppose it is in rupees, 10 rupees. Then if I assign machine A to operator 2, it is 5 rupees, and so on. These values are the positive values. These are the Cij. These values represent the cost of assignment of a job to a facilitator or a facility to some jobs. Okay, so how we are going to solve this problem? We are going to use the Hungarian method. So first step of the Hungarian method is the reduction of row or reduction of column. Why we are reducing the rows and column? Suppose we are reducing the rows, the values of the rows, by subtracting from the lowest element in the row, or in the column by subtracting lowest column in the lowest element, lowest list element from all other elements, so that we can get some zero. Zero means those values are the those columns, those cells represent the cell to be assigned the jobs, or jobs to, or facility to the jobs. Okay, so for this one, first of all, the row reduction. So first row is the list value is 5. So you are reducing 5, you are subtracting 5 from all element of this row. So what I get here? 10 minus 5, 5, 5 minus 5, 0, 13 minus 5 is 7, then 15 minus 5 is 10. Similarly, all rows you have to do this. In the second row, 3 is the minimum value. So 3 minus 3 zeros, 9 minus 3 6, 18 minus 3 15, 3 minus 3 0. Similarly, here 2 is the lowest element in this row. So subtracting 2 from all elements, this will be 10 minus 2 8, 7 minus 2 5, 3 minus 2 1, and 0 here. And similarly, 5 is the least element in the last row, 0, 6, 6 plus 5 11. This is 9, so 5 plus 4, 9 minus 5 4, and 7 minus 5 2. So this is your row reduction. See, you see every row there is a 0 here. Now then you look at the columns. In this column there is 0. In this column also there is at least 1 0. But in this column there is no 0. So we have to reduce the column in the next phase. So next step is the column reduction. Leave the rows, leave the columns where the zeros are there as it is, and then in the third column you reduce it by subtracting the least value from all elements. Now here least value is 1. So you are reducing, subtracting 1 from all other elements. So you get 7 minus 1 6, 15 minus 1 14, 1 minus 1 0, and 4 minus 1 3. So this is your after reduction. This is your reduction matrix. Ultimately you get a reduction matrix in this table. So table 3 gives you the reduction matrix. Now what happened? Now next step is the assignment of the job. Okay, you start with the first row. See, starting with the first row, box a row having single 0. So in this, suppose in this row there is only one single row, so we put a box around it. So this is the box here, and as soon as we box there, look at the column values. If there is any row, any 0 here, we have to cross that 0, because that means if I am assigning the job, assigning this job to this machine to this job, this operator, that means I cannot give any more machines to this operator. So this job has been already assigned. Okay, so but here there is no 0, so there is no point here, so I am putting 0 here. Now next you go to the next row. Next row you see there are 2 zeros here, so you leave that row, go to the next row. In the next row again 2 zeros are there, so leave that row also. Then you go to the next row. In the fourth row you see there is only 1 0, so you are going to box that row. Okay, box that 0. So we are boxing that 0. As soon as I box that 0, boxing that 0, you cross off the 0 in the other zeros in the column. So, boxing that 0, I am crossing out the other 0 in this column. As soon as you cross this one, you see that row, there is only one 0 here. So, we can box that 0 here. Okay, we can box that 0. So, B4. Okay, B4, that cell has been boxed. Okay, as soon as I box that cell, that 0, the other zeros in that column will be crossed off. So, 0 here, box here. So, this has to be crossed off. So, this is crossed off. Then as soon as I cross off there, so if there in this row there is only one 0, I am putting that box here. So, you see, cross here and then this 0 remaining in this row. So, I am just putting a box here. That means job this machine has been assigned to third operator. Then now you see, if I count the number of assignment, 1, 2, 3, 4, and how many jobs and how many persons are there? 4. So, the order of the matrix is 4 by 4. So, this is order of the matrix is 4. So, all the jobs are assigned to all the machines are assigned to all operators. As A is assigned to 2, second operator, B is assigned to the fourth operator, C is assigned to the third operator, and D is assigned to the first operator. So, all assigned start. So, say starting from, so we have gone box them across the 0 in the first column, we can box single remaining 0 in the second row, cross off the row in the fourth column, leads to the boxing of 0 in the third row and third column. So, all these things have been assigned. So, since each row and each column are exactly one assignment, so current assignment given by table 4 is the optimum. So, what will be solution here? You do not need to find out xij, because we know what is xij. Xij equal to 1 or 0. Okay. So, A is assigned to second operator, B. So, your solution is this one. You have to write the solution like this: B to 4, C to 3, and D to 1. And what is the cost? Then you look back to your original matrix. Original matrix is given by table 1. So, what is the cost of assignment of A to 2? A to 2 means cost is 5. Similarly, B to 4, I think B to 4 is cost is B to 4 is cost is 15. Similarly, C to 3 is 3, and D to 1 is equal to 5. So, you add all those costs, 5 3 plus 3 plus 3 plus 5, I think it is 15, 3 plus 3, okay, 5 plus 3 plus 3 plus 5, that cost is equal to 16. That 16 may be the effectiveness of the assigning these values, or it can be rupees in terms of rupees also. So, this is how we do the first type of problem. Now, what will happen if it is not, if you do not get number of assignment equal to number of rows or column or number order of the matrix. So, that means some of the jobs will remain as it is, or some of the jobs will not be assigned to any operator. So, how we can solve this problem? We will go do that in the next video.